Okay, hello again everyone. In the last couple of sessions we looked at logs to the base of 10 and to the base of e. So we were able to, using logs, work out problems like 10 to the power of x is equal to a by taking log 10 of a. We were able to find what x was. And in the same way, if something was raised to the power of a natural exponential, or okay, so e to the x equal to a, we're able to use ln of a equals x, and this is again just to reinforce it's equal to the same thing. Okay, so that's what we looked at in the previous two videos. That's great, but you're probably saying, okay, if something's raised to the power of 10, oh sorry, if it's 10 to the power of x or e to the power of x, I can do it. But what if I have a problem which says 2 to the power of x is equal to 29? Okay, how do you find x? Okay, so that's the question. But let's just look at the general form. Okay, if I could express this in the general form where this was log to the base 10, okay, you could say, look, log to the base 2 of 29 would give us x. Okay, so you'd say, okay, log to the base of 2 of 29, and away you go and find what x is. But then I hear you say that okay, that's great, but then I bring out my calculator. Okay, I'm looking, there's log to the base 10, that's that value, or that button, and I got log to the base e, that's that button there. Hang on a minute, where's the log to the base 2? None of them are log to the base 2, are they? So you can't just get out your calculator and press that press log to the base 2 to find what the value of x is. Okay, suddenly it becomes a little bit more complicated, which is, I guess, a problem that you would have encountered, or you will encounter in the assignment if you haven't already. Okay, so you run into this problem. So what do you do? Okay, now what do you do? It's, if you had something to the base 10 or to the base e, you could easily go to the calculator and find what x was. Okay, so what we'd really want is to try and see if we can convert that to a base of 10. To do that, I'm just going to look at this generally. Okay, if I just express this as b to the x equals a, so then to find x, okay, I would use log, okay, the base is b, a will give us x. Okay, that's sort of that is very, very messy. Okay, that's a little bit better. Okay, so that's of this form here. Okay, the 2 is the base up here, so I've just represented this in more of a general form. Okay, so how do we find x if we've got sort of an arbitrary base? Okay, we'll look at now what is usually called the change of base rule. Okay, we'll look at that. Okay, so now we have, oops, I've gone too far. We've got that situation there. We've got an arbitrary base. You don't, it's not 10 or e. What do you do? Okay, so now if we have, let's write that out again, b of x is equal to a, what I'll do is I'll take a log to some other base. Okay, log, let's say base c, okay, of b to the x, and I'll take the log of that on the other side as well, log to the base c of a. Now c could be any base, it could be 10, it could be e, but I've just called it c to just keep things general for the moment. Okay, so log to the base c, so I've taken logs of both sides, so I haven't changed anything. Now looking at the rules for logs, you'll know that I can bring this x out the front, and this is the same, saying that is equal to log c of a. Alright, now x is out the front, it's no longer embedded inside the log function. Okay, so we can now divide both sides by log c of b, so we can say x is equal to log c of a divided by log c of b. Alright, so now we have x out on its own, okay, and defined x, which was this value up here. Okay, it's log c of a and log c of b. Now what does this mean? On our calculators we have log to the base 10 or log to the base e. Let's say I chose this new base, so this is the new base. Okay, so to find x now, what I'd have to do, okay, so I'd say x is equal to log the base 10, okay, of a divided by log to the base 10 of b. Let's just look at an example using the change of base, just going back to what we had done before. Okay, so we have let's say I had again 2 to the x is equal to 29. Okay, so this here is b, okay, this is a, and that's obviously x over there. Okay, so I'd say x using the change of base rule. Okay, so this is let's say use change of base rule, okay, is equal to log 10, okay, of a of 29 divided by log 10 of b, which is 2. Alright, so I end up with, okay, so just going on there, which is equal to, so I'll just do the whole thing on the calculator rather than writing it out. Okay, so what I'm going to do is, let's clear that. Okay, so I've got log, now this is to the base 10, I can do that on the calculator now, which is that value there. So I'll say log, it's 29 divided by log of 2, oops, didn't like that, close the bracket, divided by log 2. Okay, so that's just showing you what's on the calculator there. That's representing that expression over there, okay, which is equal to, so that gives us 4.85798. okay, so we say x is now equal to 4.85798. There's a few other values that follow, but we'll just leave it at that. Okay, so now if you went back, we had 2 to the power of x is equal to 29. Okay, so and we have found x to be that. So if we were to then say 2 to the power of 4.85, which is that value there. Okay, we get our calculator back and go 2 to the power of, I'll just use this answer here, but I'll write it out. Okay, just 4.85798. okay, I haven't used the full expression, so it'll come close, but it won't be the exact value. Okay, 2 to the power of that is equal to 28.99998, which is effectively 29 if I had most likely use the full value, so that equals 29, which is where I had started up here. That's what I had wanted to find. I wanted to find what value of x. So using the change of base rule, just going back up here all the way to the top, this was to the base 10. I can't simply get a pointer, but I'll just use this. So using the change of base rule, we had looked at this before, then and that one we had looked previously. Then we said, okay, what if something is to another base, like of 2? Okay, I've worked through what the change of base rule means, how we change the base. Really, that is the expression that we should be using. So if you have that, you can change the base. I said we select the new base of 10. Okay, and using that we can find what the value of x will be. That is the change of base rule for you.